Hello everyone, welcome back to Learn with Sravs. Today's video we are going to learn arithmetical ability and the first topic is operations or numbers. Okay, so let's begin with the numbers. Numbers in the Hindu-Arabic system. Okay, Hindu-Arabic system, and we are including 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. These 10 digits are used to form all other numbers. Okay, so a number is representing using for place value chart, which helps us understand the value of each digit and depending on its position. So the Indian place value system in places are ones, tens, hundreds, thousands, 10,000, lakhs and 10 lakhs and crores and 10 crores. For example, the number is 6 crores 3 lakhs 8,951 is read. So in the numerical, the number name is 6 crores 6 crores and 3 lakhs 80,000 and 951. Similarly, another like a number to read it. By using this place value chart, we can easily to read and write in large numbers is correctly. We can take first and 8, 5, 4, 1, 6, 0, 0, 8. In the 8 place value is units, ones, and 0 is tens, and 0 is hundreds, 6 is thousand, and 1 is 10,000, and 4 is lakhs, and 5 is 10 lakhs, and 8 is crores place value. So start with crores. 8 crores, like 10 lakhs, then 4 lakhs, so 16,008. Okay, 8 crores 54 lakhs 16,008. This is the answer. So check another one. Okay, 2 3 8 0 9 1 7. Okay, 23 lakh 80,917. Okay, by using the place value chart, we can easy to write and read in large numbers. Okay, so next we discuss the writing the numbers in figures. Now let's learn in the convert words into numbers. Okay, so for example, take 9 crores 4 lakh 6,002. So this is the place value of 9 crores. So 9 crores 4 lakh, place value is 4 lakh 0 6,000 0 and the 0 10 hundreds value 0, tens value 0. So once 2 9 crores 4 lakh 6,002. Okay, the place value chart helps us to place every digit its correct position. Next we discuss in face value and place value. Okay, now let's understand two important concepts like a face value and a place value. It's like face value is the actual value of digit no matter where it is placed in the number. Okay, for example, in the number is 7,984. The face value of 4 is simply 4. The place value depends on the position of the digit. Okay, for example, the digit of 4 in the ones place, so its place value is 4 into 1 is equal to 4. If the digit were in the tens place, its place value would be digit into 100. So if were the thousands place, the thousand value would be digit into 100 and so on. So face value never changes, but place value changes according to the position of the digit. Okay, so did you understand the face value of the digit is simply the digit itself. So it's never changes and no matter where the digit is placed. For example, take one number like 87 lakhs 392 and 895. Okay, 87,392 into 895. Okay, this is the. Let's look at the digit of 7. So its face value is simply 7. Similarly, the face value of 9. Okay, 9 is 9. The face value is 5 is 5. So remember one simple rule. Face value is the actual is equal to actual digit. So no multiplication, no position, just digit itself. So what is place value? Now let's understand the let's understand the place value. So place value depends on where the digit is located. So every position has a value: ones, tens, hundreds, thousands, 10,000, lakhs, 10 lakhs, crores. So we multiply the digit by the value of this position. Let's see the for examples and some examples given on the page. So suppose the digit 7 in the tens place. So then 7 into 10 lakhs, okay, 7 is equal to 70 lakhs. So its place value is 70 lakhs. Now the digit is 9 is in the tens place, like uh, 10 is tens place, 9 is in the tens place. So 9 into 10 is equal to 90. So for example 7 into uh, 7 is in the 10 lakhs place. So 10 into 7 into 10 lakhs. So answer is 70 lakhs. Okay, so it is the place value become into 70 lakhs. So similarly digit is 4 in the thousands place. 4 into 1000 is a 4000. So always remember, face value never changes. Okay, face value is never changes. The place value changes according to the position. Did you understand? So next one is the types of numbers. So already we know that, and various types of numbers. So first one we discuss in natural numbers, one of the type of numbers. So counting numbers are called natural numbers. Okay, natural numbers are counting numbers. Okay, so they start with 1. So 1, 2, 3, 4, 5, 6, so on. So notice that 0 is not include natural numbers. Okay, so the next one is whole numbers. All counting numbers and 0 form the set of whole numbers. So whole numbers including 0. So include 0. So start with 0. 0, 1, 2, 3, 4, 5. This is only its difference. Natural numbers begin with 1. Whole numbers begin with 0. That's only difference. So start with 0 and so on. So clearly every natural number is a whole number and 0 is a whole number which is not a natural number. Okay. The next one is integers. Integers, all counting numbers, 0 and negative of counting numbers from the set of integers. So, and integers include positive numbers and negative numbers also. So, and including with 0. For example, -3, -2, -1, 0, 1, 2, 3. So integers extended in both directions. The next one is even numbers. Even numbers, a counting number divisible by 2 is called an even number. So every even numbers are numbers divisible by 2. For example, 2, 4, 6, 8, 10, 12. Every even number each ends with 0. Like 0, 2, 4, 6 or 8. That's okay. The next one is odd numbers. Odd numbers, a counting numbers not divisible by 2 is called an odd numbers. So odd numbers are not divisible by 2, like 1, 3, 5, 7, 9, 11, 13. These numbers leave a reminder of 1 when divided by 2. So next one is a prime number. A counting number is called a prime number if it has exactly in two factors, namely itself and 1. So prime numbers have exactly in 2 factors and 1 and the number itself. Example 2, 3, 5, 7, 11, 13, 17, 19. Notice that 2 is the only even prime number. Every other even number has more than 2 factors. Okay. Next one is, now let's understand composite numbers. So a composite numbers is a number that has more than 2 factors. Remember, prime numbers have exactly in 2 factors and composite numbers having 3 or more factors. Example like 4, 6, 8, 9, 10 and 12, 15, 21. So let's take 12. Okay, and its factors are 12 and 1, 2, 3, 4, 6, 12. Okay, you can see there are 6 factors. Since it has more than 2 factors, 12 is called a composite number. Okay, and so let's take another example. So take 15. So 15 factors are 1, 3, 5, 15. Okay, so again more than 2 factors, so 15 is also as a composite number. So remember that important point, every composite number can be divided by some number, so other than 1 and itself. Okay, so now we discuss in co-prime numbers. Okay, co-prime numbers. So now let's learn another interesting concept. So many students think co-prime means both numbers should be prime. Okay, so that is wrong, because co-primes numbers are two numbers. Okay, two numbers and whose highest common factor or greatest common factor divisor so is 1. Let's understand with an example. First you take the 4 and 9. So factors, like take 4 and 9. Okay, take 4 and 9. So factors of 4, so factors of 4, 1, 2, 4. So 9 factors are 9 factors are 1, 3, 9. The only common factor is 1. Okay, so let's see this. And 4 and 9, factors of 4 are 1, 2, 4. So factors of 9 are 1, 3, 9. The only common factors are 1. Okay, so therefore 1 and 9 are called a co-prime numbers. Okay, notice something important, neither 4 or not 9 is a prime numbers, but together they are co-primes. Another example is take 8 and 15. Okay, so first you take 8. 8 factors are 1, 2, 4 and 8. Okay, same 15 factors are 1, 3, 5, 15. Again, only common factor is 1. So, 8 and 15 are also co-prime numbers. Did you understand? Next concept. I think you understand this concept. Next one we discuss about tests of divisibility. So now we are starting one of the most important topics for competitive exams. So instead of dividing every number, so we use some simple rules and they are called a divisibility tests. Okay, so they help us answer questions within seconds. Let's learn them one by one. Okay, first you take that divisible by 2. So a number is divisible by 2. A number is divisible by 2 if its units of is any of 0, 2, 4, 6, 8. Okay, so if its last digit is 0, 2, 4, 6 or 8, these are all even digits. Okay, so take one example. So 8, 6, 4. Last digit is 4. So since is even, 864 is divisible by 2. So let example 5, 8, 6, 9, 4 is divisible by 2. Why? Because last digit is 4. So since 4 is even, that's why 5, 8, 6, 9, 4 is divisible by 2. Suppose while we take in 8, 6, 9, 4, 5 is not divisible by 5 because last digit is 5. It is not a even number. It is a odd number. That's why not divisible by 2. Okay. And only the shortcut is very simple. First just check the last digit. It is divisible by 2 or not. You understand? Okay. Next one is divisible by 3. So a number is divisible by 3 only when the sum of its digit is divisible by 3. For we don't look at the last digit, instead we add all the digits. If the sum is divisible by 3, the original number is also divisible by 3. Okay, for example, take 8, 6, 4. So add 8 plus 6 plus 4. How much? 18. So 18 is divisible by 3. it is divisible by 3. Therefore, 864 is divisible by 3. Let's take another example. Okay. So, in the number 6, 9, 5, 4, 2, 1, the sum of digits to add 27. So, which is divisible by 3. So, let's take another number, you check. Okay, first 7, 4 plus 2, 13. 13 is not divisible by 3. Therefore, 742 is not divisible by 3. Okay, did you understand? Next, the rule is almost the same, divisible by 3, add all the digits. Okay, so if the total is divisible by 9, the number is divisible by 9, for example. So let's take one example divisible by 9. So 2 plus 4 plus 6 plus 5 plus 9 plus 1, like 2 plus 4 plus 6 plus 5 plus 9 plus 1. So total digits at just 27. So which is divisible by 9? So 2, 4, 6, 5, 9, 1 is divisible by 9. So next example is 7 plus 3 plus 4 plus 5 plus 1 plus 9. The sum of digits are 29, which is not divisible by 9. So then it is not divisible by 9. Okay, so let's understand this concept. What is this rule? Like divisible by 9 and divisible by 3 is almost the same rule. Okay, the rule is almost the same, like add all the digits. So next divisibility by 4. So divisible by 4, like we only check the last digit, and if those two digits from a number divisible by 4, so the whole number is divisible by 4. Okay, let's check. Okay, 6, 8, 7, 9, 3, 7, 6. Okay, is divisible by 4, since because 76 is divisible by 4. That's why this number is divisible. 864 is divisible by 3. Let's take another example. Okay, so in the number 6, 9, 5, 4, 2, 1, the sum of digits to add 27. So which is divisible by 3? So let's take another number, you check. Okay, first 7, 4 plus 2, 13. 13 is not divisible by 3. Therefore, 742 is not divisible by 3. Okay, did you understand? Next, the rule is almost the same, divisible by 3, add all the digits. Okay, so if the total is divisible by 9, the number is divisible by 9, for example. So let's take one example divisible by 9. So 2 plus 4 plus 6 plus 5 plus 9 plus 1, like 2 plus 4 plus 6 plus 5 plus 9 plus 1. So total digits at just 27. So which is divisible by 9? So 2, 4, 6, 5, 9, 1 is divisible by 9. So next example is 7 plus 3 plus 4 plus 5 plus 1 plus 9. The sum of digits are 29, which is not divisible by 9. So then it is not divisible by 9. Okay, so let's understand this concept. What is this rule? Like divisible by 9 and divisible by 3 is almost the same rule. Okay, the rule is almost the same, like add all the digits. So next divisibility by 4. So divisible by 4, like we only check the last digit, and if those two digits from a number divisible by 4, so the whole number is divisible by 4. Okay, let's check. Okay, 6, 8, 7, 9, 3, 7, 6. Okay, is divisible by 4, since because 76 is divisible by 4. That's why this number is divisible by 4. So another number, check another number, 4, 9, 6, 1, 3, 8. So last digit is 8. So 38. so is not divisible by 4, since 30 is not divisible by 4. Okay, you can check this rule is you can check in last two digits. Okay, let us revise all these concepts. First, divisible by 2, check in only in last digit, and that is divisible by 2 or not. Okay, the next one is divisible by 3. This rule is add all the numbers. Okay, 6 plus 9 plus 5 plus 4 plus 2 plus 1, so 27. Then that's why 27 is a divisible by 3. The 9 is also the same rule. Okay, add the whole numbers and divisible by or not, divisible or not, check. Okay, that's, and divisible by 4 is this rule is changed, so check the last two digits. Okay, the next divisible by 8. Now let's move to divisible by 8. Here we check only the last three digits. Okay, you can check in last three digits of the number. So if the number is formed by the last three digits is divisible by 8, then the whole number is divisible by 8. Okay, so for example, consider the number is like take 2 5 4 8 1 6. We do not divide the entire number, so instead we look only the last three digits. Okay, so the last three digits are 8 1 6, so 8 1 6 divided by 8. Okay, so the answer is 1 or 2. There is no remainder, so 2 5 4 8 4 8 1 6 is divisible by 8. Okay, so this is divisible by 8. So take another number. So 1 2 3 4 5 8. So last three digits are 4 5 8. So 4 5 8 divided by 8 leaves a remainder. Okay, only consider this one. So 1 2 3 4 5 8 is not divisible by 8. Then because for divisibility by 8, always check only the last three digits. Okay, next topic is divisibility by 10. So divisible by 10, this is the easiest rule. Then a number is divisible by 10 only its last digit is 0. So 120 or 440, 980, like 7 8 4 9 3 2 0, last digit all the end of 0, so they are divisible by 10. Now look, 125, the last digit is 5, so it is not divisible by 10. Okay, next one is divisible by 5. So divisible by 5 is its last digit is 0 or 5. Okay, 0 or 5. So for example, 75, 120 and 345. So and 76,895 and 68,790, like that. So all end with 0 or 5. It is divisibility by 5. Okay, so now take 348 is end with 8. Okay, so it is not divisible by 5. Next one is divisibility by 11. This rule is similarity to and different, so but once you practice it becomes easy. So let's understand the step by step. I will explain. First, add the digit is odd positions. First you take one number. So this is the number. So some of its digits are at odd place and some of the digits in even places. So find the difference between two sums. Okay, if the difference is 0 or divisible by 11, then the number is divisible by 11. Okay, like take one some odd numbers, this number, and like 7 4 3 9, odd numbers, and 1 5 2. Okay, like to calculate this sum, so 23 minus 12 equal to 11. So which is divisible by 11? So this number is divisible by 11. And consider another number. Take a 5 4 7 4 and 6 3 8 2 2. So take 2 8 4 7. Sorry 6 and 7. So 2 3 4 and 5 is an even number. So to calculate, add these numbers, and 23 and 14 equal to 9, which is not divisible by 11. Okay, it is only in 0 or 11 to divisible by 11. Okay, so this is very common aptitude questions. So practice these rules and several times so it is easy to understand. Okay. So I will explain this easy to learn. So now let's solve the examples. Give so like whenever you solve the questions, first you identify which divisibility rule is available and applicable, and apply the rule step by step, and explain why the number is divisible is not divisible. So finally verify the answer. This approach to this logic is very instead of simply to memorize these rules. Okay, so that's it. That's it, guys. So that all for today's class. In this session, we learn about prime numbers, composite numbers, and co-prime numbers, and divisibility rules like a 2, 3, 4, 5, 8, 9, 10, and 11. I hope you understood all the concepts and clearly. So in this next video, we will discuss and solve the exercise questions and from the chapter step by step. So I will explain each question in detail and discuss the simplest method to solve them and share useful shortcuts for the competitive exams. So if you found this video helpful, and please like the video and share it with your friends and subscribe to this channel and for more aptitudes and arithmetic lessons, and don't forget press the notification bell so you never miss our upcoming classes. So thank you so much for watching my video. See you in the next class.